In today's lesson, we're going to be going over dependency injection, and this is going to be applicable both to UIKit and SwiftUI, because I'm going to be doing this in a very generic way using a command line. And this is very similar to just playing around in playgrounds, so it's easy to follow along and it can be applied anywhere. So the first thing I want to cover is a very simple example of dependency injection. And to do that, let's go ahead and start by creating a class, which can be a data class, and this can be where you store your data, for example. And it's just going to have a sample variable called data, which is going to be just a string that says data. And then let's go ahead and pretend we have a view model. So here we go ahead and create our view model, and as always, we need to refer to the data class if we want to grab the data. And it's very tempting just to go ahead and type in let data equal the data class, so that we can actually access the data. And then we can go ahead and create some sort of function that says do something. And inside there, we'll just print the data.data, which of course is linked to this part right here. Now, if we go down below that, we can go ahead and create an instance of our view model, which is going to equal the view model, of course. And we can call do something. And if we run that program, it's going to print data at the bottom. As you can see, it printed data and the program ended. Now, let me actually correct what I said. This is not an example of dependency injection. This is just how we would do things without dependency injection. But as you can see, this eventually will become unmanageable, especially if we want to access the data from many parts of the program. Now let's go ahead and create a very simple example of dependency injection. So instead of having this explicitly written, we're going to go ahead and just say that we have a variable of data, which is going to be of type data class. And this actually has to be a variable. And instead of initializing it immediately, we're going to go ahead and create an initializer that requires a data of type data class. Then we're going to set the data to that data. Now, when we actually instantiate the view model, we have to go ahead and call data and insert the data class, the instance of data class that we want to use in the view model. Now, this already makes it much more flexible because we only have to change it in one place and it's going to update it automatically in the view model. And of course, if you rerun this program, you're going to have everything working exactly the same as earlier. We can still access self.data, but now if we want to create a different class, such as a second view model, we can just go down here, class view model 2. We can still refer to it by calling the data class. And not only that, if the data class has a custom initializer, such as what kind of data do you want, we can go ahead and type in var sample text of type string, and we'll create an init that takes some text of type string. And inside here, all we have to do is say self.sampleText is going to equal the text. So if we had some random initializer like that, now we can actually go ahead and improve this by actually calling the text that we want to insert. So here we can say hello. And if we want to create a second view model, we can go ahead and type in let vm2 equal view model 2 with the data of data class. And here we have another custom initializer that can say goodbye. So this just makes it a lot easier to manage what we put inside there. And as you can see, we can add any custom initializer and we can adjust it to meet the needs of the view model. So that's a very simple form of dependency injection. As you can see, we put it once in here and it drags it down along the line into the view model, and then we just use it there freely. We're not dependent on creating it here, and we can update it as long as it conforms to the data class protocol. But let's go ahead and delete the second view model to make this a bit more clean. And we're going to remove the initializer and the sample text because that does absolutely nothing. And we need to remove this text. So in its bare form, it just makes everything a lot more manageable. As you can see, all we have to do is state it once where we need it when we want to initialize it, and it's going to go down along the line into the next place. But in this video, I want to take it a step further. What if you have multiple dependencies that you want to take care of? And how can we make that actually manageable for us in SwiftUI and UIKit? So we're just going to get rid of all of this stuff over here. And the very first thing I actually want to do is go ahead and create a new file. So hold Command+N, click on Next, and we're going to call this DI manager, and this is going to be our dependency injection manager. So this is actually going to be a video based off an article I read on Medium, and I'm going to leave this link in the description down below in case you're curious about it. It's going to look like this: SwiftUI dependency injection in 20 lines of code, and it's just a helper method, or actually a property wrapper, that makes injecting classes and dependencies so much easier. And I just wanted to discuss how that actually worked. So let's get started by creating what they wrote in that article. So the first thing we want to do is create a struct, which is called dependency injector. And inside here, we're going to have a private static variable, which is called a dependency list. And that's going to be of type string, and it's going to hold any. And initially, it's just going to be an empty dictionary. So the idea behind this is that we want to store the instances of the classes that we depend on. So we're going to have a key, which is going to be a string, so we can retrieve the dependency we're looking for. And we're going to actually store the instance inside this dictionary. So that's just the idea behind it. So we can call it anywhere we want just by referring to the dependency injector. So we're going to have a static function called resolve, and this is going to help us find the dependency that we're looking for, and it's going to return t. So we're going to guard let that t is inside the dictionary. So here we have to go ahead and type in dependency list, and as the key, we're going to look for the key, which is going to be a string describing t.self. So what this means is that the class that we are trying to find is going to be in a string format. So if you have a class that says, let's say, data class, t.self is just going to be the name data class. And we want to cast that as its original form of t, which is the class itself. Else, we're going to throw an error, which is going to be a fatal error, which means we did not actually put the dependency inside this array, so the program should crash. And this is going to be a logical error, so this is absolutely fine. Fatal error should never be reached if you are good with your logic. So here we can type in no provider registered for type and then backslash t.self. And if it works, we're just going to go ahead and return t, which is the class that we want to inject. And there's an error here because I forgot the parentheses after this generic. So once again, this is going to take care of retrieving the dependency we need, whether that's a data storage or some sort of helper class. It's going to retrieve it just by finding the name of it and casting it to the actual class. And we also need a function that's going to insert it into this dictionary, and this is where we're going to actually provide it. So this is how we inject it, and the next function is going to be how we provide it so it can be injected. So we're going to type in static function register, which is going to take a type of dependency of type t. So inside here, we just need to insert the dependency. And to do this, we're just going to call the dependency list. And as the key, we're going to create a string, which is going to be describing the class that we are injecting. So here we're just going to type in t.self. And for that key, we're going to place the dependency itself. And it was as simple as that to create the register function. Now, if you want to create dependency injection, this is enough, but I want to take it a step further. And we're going to be creating property wrappers to achieve that. So here we're going to create a property wrapper, and it's going to be a struct called inject, which takes a type of t, and what it's going to do is inject the value into any class we want to use it. So first, we need to go ahead and create a wrapped value, which is going to be the value we use it on, and it's going to take an initializer. And the initializer is going to say self.wrappedValue is going to equal the dependency injector.resolve. And just for debugging purposes, we're going to go ahead and print injected with a small arrow. And we're also going to add the self.wrappedValue so we can see what we are injecting. So that takes care of retrieving the value from our list of dependencies. Now we can go ahead and copy this and paste it right under. Because inside here, we're going to create a provider. And again, the provider is a way of inserting it into the dictionary or the array so that we can retrieve it later. And it's very important you call the provider always before the inject property wrapper, because if it looks for something that doesn't exist, again, it's going to throw a fatal error. We want to make sure we're grabbing something from the array that actually exists. But inside here, we actually need to change this a bit. So we're going to go ahead and type in self.wrappedValue is going to equal the wrapped value. Then the dependency injector is going to register this, and the dependency is going to be the wrapped value. Then we can go ahead and copy the print statement, and instead of injected, we're going to type in provided and reverse the arrow. And we have an error here, and that's because I forgot to add the wrapped value inside here, which is just going to be a wrapped value of type T. So just like that, we've created the two property wrappers that we need to create this multiple dependency injection. And I also want to mention that all of the source code will be in the description box down below. So just click on that link and you'll find it on GitHub. In case you want to look at it and copy it or play around with it, feel more than free to do so. But now we can move on to the next part, which is how to actually use all of this stuff. So to further demonstrate this, let's go ahead and create a class, and it's going to be a Swift file, but it's going to be called sample classes. So these are just some classes you want to use in your program, for example. Maybe it's a class that creates an API request. It's just a place to put your generic classes. But one thing I want to do and get this out of the way first is create a protocol. And the protocol is going to be called data protocol, because we're going to create a data class. And this data class is going to have some data, which is going to be of type string, and it's going to be both get and set. Then we have a function that says set data, and it's going to take some data of type string, and a function that says get data, which is going to return the data we want. So that's a protocol, and I'll explain why we made this protocol later. It's just good that we make some classes that conform to this protocol, because it's going to increase the flexibility of our dependency injection. So for now, let's go ahead and create two sample classes. The first one's going to be a class called data storage, and it's going to conform to the data protocol, the one we just created. And it's going to ask us to add the protocol stubs. So go ahead and fix that. So we have it all pre-made. Now inside here, I want to go ahead and include a variable called test mode, which is going to be of type Boolean. Then we need to create an initializer, and it's going to take test mode, which is of type Boolean, of course, and we're going to assign self.testMode to the Boolean. Now, if the test mode is activated, we're going to return this sample data. So self.data is going to equal this is the original storage. Else, we're going to return self.data is equal to no data stored yet. So it's a simple initializer. If test mode is on, we have this sample data, otherwise we have no data at all because we're actually running the app. Now for the other functions, we can just go ahead and say self.data is going to equal this data, and getData is just going to return the data. So they're not really meaningful functions, but it's good for this example. So now we have this class that conforms to the data protocol. And we're also going to create something which is going to be called a data formatter, and the only thing it's going to do is format something, which is going to take the data of type string, and it's going to return a string. So all we are going to do is return the data.uppercased. So it's another example of a class that does something, and again, this is not really that meaningful, but it's good for the example of this program. Now with this class being written, we can go to our main file, which is usually where you run your command line. And inside here, we're going to create a class called dependencies. And as the initializer, we're going to go ahead and set up the dependencies we want to use throughout the app. And to do this, we need to call the @provider. And for example, if we want to use the data storage in the app, we're going to go ahead and call our data storage, and we're going to create an instance of it. So data storage with test mode set to true. And it's important that we specify it as data protocol. And this just means that any kind of class that conforms to the data protocol can be used in combination with this data storage. And I'll show you towards the end of this video how this actually can be applied. But right here, all you need to know is that we created an instance of it and we stored it inside the dependency injection dictionary. And let's go ahead and create another one, which is @provider var data formatter. And that's just going to equal an instance of data formatter. And of course, we need to go ahead and also make sure that we actually initialize this class. So go ahead and say let dependencies equal dependencies. And just by doing that, it's going to initialize the class and it's going to call these two property wrappers. And this doesn't have to be put inside a single class. You can literally put this anywhere you want. You just need to make sure you use these before you actually call them in the class that you want to use them. For example, right here, I'm just calling it to make sure that we initialize these and that we have them inserted. But now let's go ahead and create a class called app_stuff. So this is where all the stuff in your app happens. And let's pretend we actually want to use the data storage and the data formatter. To do this, all we have to do is go ahead and inject them into this class. So we can go ahead and type in var data storage is going to be of type data protocol. And we're going to go ahead and inject var df, which is going to be of type data formatter. And I realized I made a typo here before because there is something called a date formatter, which is extremely close to data formatter. So I wouldn't recommend using data formatter as a name, but just make sure you change that to data formatter because that's extremely important that these are both the exact same type. But just like that, we've successfully injected that into our app_stuff class, which means we do not need to create an initializer to use these two variables. They're already initialized by our dependency injection manager. And just to demonstrate that, let's go ahead and create some functions. One's going to be a function called store data, and it's going to take some data of type string, and it's going to call the data storage dot set data with the data as the data. Then we're going to have a function called view data, which is going to get some data, and that's going to be the data storage dot get data. So that's the current data in our storage. Then we can go ahead and print that data. And finally, a function that says format data. And it's going to be more or less the same thing. We're going to retrieve the data. So let data equal data storage dot get data. And we're going to print df dot format something, which is going to be that data. So it was that easy to use what we've injected into our dependencies just by calling the @inject property wrapper. But now let's go ahead and actually use it. So here we're going to go ahead and type in let app_stuff equal an instance of app_stuff, and then we're going to call app_stuff.viewData and app_stuff.formatData. And if we run the program and everything worked well, we should see the whole process being applied to our classes. So first we're providing the dependencies it needs, which is the data storage and the data formatter. And then every time we inject it, we're retrieving that. So as you can see, we just need to make sure that we have a data storage provided if we want to use it later. And if we actually go ahead and comment out one of these and rerun the program, it's going to throw a fatal error because it's not going to be able to find the class that we're looking for. It's going to provide this one and it's going to inject this one, but it's not going to inject the other one. So it's very important that you actually provide them ahead of time and make sure that they're provided before they are used. And that's why it doesn't really matter that it all happens at the same time. It can be immediately before you actually use something. Just make sure you have this provider set up before you use it. Okay, so you might be thinking that was actually a lot of work for such a little outcome. But now let's go ahead and see what happens if we create a random class again, such as example class. And here we're just going to do the same thing as earlier. All we have to do is copy these two and inject them down here. And the initializer is just going to go ahead and print example class init. And we're just going to call data storage.getData. And now we need to go ahead and create an instance of that. So instance example class, which I'll just call EC, is going to equal example class. And by creating this instance, we're going to call the initializer. And if we rerun this program, you're going to notice that first it's going to provide these two. It's going to inject these two in the first class where we use it. It's going to use that data. And then when we use the next class, as soon as we use it, it's going to inject them once again. And it's going to use the example class. And the best part about this is that we only have one instance of each one of these classes. So we're not going to have any memory leaks and it's going to be very easy to manage. Now there's still one very important part to cover, and let's just go ahead and remove this part over here. We do not need the example class for this example. And that is, why do we have this data protocol? So let's go back to our sample classes. And inside here, as you can see, we have a data storage and it conforms to the data protocol. And the reason I did this is because in production apps, or actually when you're testing and creating an app, it's very likely you're going to have some mock data. And here we're going to go ahead and create a mock data storage. So it's going to be more or less the same, except here we can go ahead and print This is a mock data storage, and everything else is going to be the same, but we're just going to simulate that we have some dummy data that we might want to preview or we might want to test. So dummy data. Now, the benefits of using the data protocol that we've created up here is that we can go to our main file, and instead of using data storage, we can actually insert any class that conforms to the data protocol. So here we can go ahead and type in mock data storage. And if we run the program, we're going to have it work perfectly. We're going to still have it compile, except this time it's going to compile with the mock data. So you just had to switch out this data storage with another storage that conformed to the data protocol, and you were able to test it the same way, with just one line of code having to be changed. So that is the main benefit of using this dependency injection, is that we can make small changes that affect a lot of our code. But with that being said, that's actually all I wanted to cover in today's lesson. And don't worry if you didn't understand everything all at once. We are going to create apps in the near future that are going to cover this in further detail, or actually with live examples using SwiftUI. But this is the main concept behind how you can create some very simple dependency injection and how it can just make managing your app so much easier by making sure that you can use the class anywhere you want just by using a simple keyword, and that if you want to update this at any point in time, you can just change it in one place, and that's the place where you provide it. So with that being said, as always guys, thanks for watching, and I'll see you in the next video.